What unit do we have here? HMV105. So it has the, is this an E1 control on the back here?
It is.
Now how come on this one, the control looks like it's just this one solenoid in here, it's not a whole lot.
On the pump it's on the outside, so you can have your two solenoids, or you can have your hydraulic ports, or your mechanical to drive it from A side to B side. On this one, you don't need to have it to go from A side to B side. They could do it with, they got a solenoid, and then they got a valve with another valve inside. So they can use it all internally in the back end.
And all a hydraulic motor does is it turns hydraulic power into this mechanical rotary power. Now with this control then, though, it still needs to go both sides of center, right?
Correct.
So it's still capable of doing it, but it just maybe doesn't have some of the other adjustments and so forth that are on it.
Yeah, it's just
okay.
Milliamps, sends it one way, sends it the other way.
Because really this is more just receiving pressure.
Yeah, because you got your pump that's driving it. You got your pump being pushed to the one way, it's going to go from min to max. So you're telling it which way to go by supplying the oil to it.
That's right. So the controls is just, it's not necessary to have the controls on the motor because it's just receiving what the pump is giving it anyways.
Yep, it just determines the displacement.
Let's say it's going full speed one direction. How quickly could it stop and then go full speed the other direction?
As fast as your pump can send the signal, and it's not going to break anything really.
Because when you're on the test stand, you really give it the.
Yeah, well, usually on the test stand, what we do is we run it at a minimum of 1,000 RPM, so that way we know we're giving it a pretty good load. And our hydraulic signal, it activates it in milliseconds. So you can go from this one goes from 105 cc's at full displacement, and then we're changing the minimum displacement to 57 cc's. But you can have it anywhere from 37 to 75, I think.
Does this have any volume stops on the motor?
Yep, it's got a max volume and a min volume.
And so when you're saying you're changing them, you're just mechanically going on there with a wrench?
Mechanically set so it cannot go lower.
When you are setting it, how exact do you need to be? Do you feel like, oh, I got to be right on, and you're tinkering with it to get to that 80? Or is
we can make it pretty much exact. We can set the flow, so on our graph we read the flow, we do the math calculations, and we can set it, like you can tweak it to within a couple RPMs or higher.
So in this one here, there's actually a rubber seal in here?
It's like a glass pack seal, kind of like a loaded seal.
Because the Parker ones, like the P2s, for instance, it's just metal on metal, right?
Yeah, that's the type of seals that they have in there.
So this one has actually like a servo seal.
Yep.
And why is there two in here? Do they both go in? One a stopper and one's a...
So this one goes inside and it'll seal around it, the piston. And then this one goes on the outside. It's like a wearman seal, glass pack type.
So you really need to get these from the factory. You can't get anything.
Yeah.
But I see that now here has this body seal here. I thought that they used like gasket eliminator.
They did on a lot of the 01 series, and at the beginning of the 02 series, they were using the gasket, but they've come this way to start going with the O-ring.
Probably simplify the...
Oh, it makes repairs a lot easier.
Because you used to spend an hour just cleaning it up.
Yep.
And so now that's no longer a thing.
Exactly. I think it was 2010 or 11 where they almost, everything after that has been...
Okay. Well, you remember when I first started here, I was back here.
Oh yeah, Saturday.
Probably 3/4 of the day.
Oh yeah.
Trying to figure out what it is I was selling. You can see there's a better view of that servo seal there. And this looks like to be a smaller unit. What is it, 75?
I think that's a 105 too.
Do you heat the whole thing up, or do you just heat the areas that you're doing?
Where I'm going to work.
Now this is a small piece though, right?
Yes, so it doesn't need excessive preheating. It's just three-quarter mount steel, so
So it's not brittle or...
Okay. I'm not doing like multiple passes, so I just need one pass, yeah.
Well, let's see you start this thing up. And so no oxygen is required with this stuff, right? That's just like your barbecue. And you're saying that, so would you always preheat this though, but some people might not preheat?
Preheating is good.
Okay.
It gives you good penetration when you are welding, yeah. Even if just a little bit for like a minute or two, I think it's way better than not preheating, yeah.
Is there any particular area you like to start?
No.
Just whatever needs welding, right?
I think it all depends on your, like, how much experience you have, right?
Right. All right, let's see your stuff here. I'll wash my eyes. So this one you actually started halfway in. That's just because you've done this so many times, you gotta start somewhere, right? All right, fair enough. Just a quick little once over.
Just part of it. It's easy to clean.
Yeah. It's pretty good. And if nobody trusted anybody, every single thing would require a 30-page contract and bonds and collateral and all that. Trust is good for everybody.
They have to see the process that we do.
Right. They need to trust that we are doing things properly here when they buy this. Because they're not going to believe the salesperson. The salesperson will just tell them what they want to hear, but they will believe the welder that made it. So if something cool is happening,
no, and this is a really good product that we have here.
a very good product. Huh?
So the other valve that we used to use, from what I know, they work with solenoids, and this one works with frequency. So it is hertz. It is more sensitive at the time of pressure.
These solenoids are different than the other valves, is that what you're saying?
The functionality of the valve is different, yeah.
A normal proportional solenoid works on force,
Okay.
works on amperage. So you put amperage to a coil, it gives a certain force which will move the spool across. Big benefit of these valves actually work with what they call pulse width modulation. So they actually put 24 volts to it on and off very fast, which controls the spool movement. So it's not amperage. So anytime that you have something that's always in motion, it will respond faster because it doesn't have to accelerate, de-accelerate. Where a force coil could stick, it would have a little lag. So if you're in a man lift and you're 40 feet up in the air,
Okay.
and you go to hit the joystick, if you had a regular solenoid,
Lurch forward.
it would lurch you badly, where this would give you a lot finer control.
Oh, because it's always in
So
continuous.
these, almost any man lift, anything with a person in it, uses a pulsar type valve.
Is that just a metering in and metering out type thing?
Yeah.
If this was perhaps a man lift, this one would be the raising and lowering, forward, backwards, steering.
Steering, track. There's a couple spool sections in there that are rated for 30 gallons a minute. There's one of the sections here rated for 2 gallons a minute.
So you wouldn't just put them all 30, even if you're only using 2. So you can get that. You can get even extra fine tuning there with that. So they're really hyper specific to exactly what they're trying to accomplish there. And how did you know that one's a 30 and one's a 2 gallon? Can you see it when you open it up, or is it just put on the drawing, the model code?
Actually, the spools are marked.
Now, how come this one has larger ports than all the other ones?
This is the pressure in and out.
Oh, so that's sort of like the main line going in.
P&T.
Right, and then this is the one going to each one of these functions. So how much flow would be going into here? Like, for instance, could you use all of them at once?
That's another benefit. This valve is the first one. This is a bypass inlet, so it works with a fixed displacement pump. When you select a solenoid, it sends a signal to this. It's load sense. So then you can actually have limiters. You can actually set the pressure for each function.
So it's only using the energy that are required.
Yep.
So it is quite efficient then, and that's why they're using a fixed displacement, because a pressure comp would be to save energy. But if this is able to do it,
this is almost as good. A lot less money on the pump valves.
Now, are these things expensive though?
Yes.
Yes, they are.
So these are actually like servos in there, meaning that's a small amount of pilots.
Pilot operated,
That's
yeah.
right, pilot operated. Okay. Well, that's good then. And I believe that these were on a drill rig.
Anytime you'd have a long boom, you need fine control.
Right.
And then you would have the drill head, the drill spinning, robbing the tracks.
It's a VAL 3910. Do we know what the 3910 means?
They're all custom
But the series is the VAL series?
VPL.
VPL? And
VAL is this whole valve assembly.
okay, but the series is the VPL series, also called the Pulsar series.
These valves didn't work correct.
Oh, this is
Okay.
a good part.
What was the cause?
So now, when they say it didn't work correctly, we assembled these, correct?
Yes.
From parts.
Yeah.
So we got a drawing
From the customer.
from the
assembled-
customer and assembled this as per the drawing. But so did we not assemble it correct, or was the drawing incorrect?
Drawings.
Well, that's nice to hear.
2 little balls extra.
Extra. Big difference.
So were these some checks somewhere?
Yes, on the load sense line. And what was happening, the bypass valve, after we cycled it a couple times, was locking up. Because the pressure was getting trapped, because these balls were installed where they shouldn't have been.
This is us testing these. Then we have to plug them all, and then you just keep
putting different things in.
moving down the line here, right?
We hooked it up exactly the way it was going to operate. And so normally the oil would come in up to 30 gallons, and 30 gallons would go back to the tank over the bypass valve. It needs to connect into the other block and then bleeds the tank at the end.
How does it determine how much flow is coming out of here and pressure? Is that set somewhere?
Well, 30 gallons will come in, 30 gallons bypasses here. Now, when this end spool requires 2 gallons, 2 gallons will go out this line, 28 will go out. This is just like a load sense pump. Right. The signal goes in there, and then it supplies whatever the valve spool requires.
Now, what type of connector is this? Is this a Deutsch, or is this some? Looks like a little special.
It is.
Yeah.
To Pulsar.
To Pulsar. So
And it makes sense that they have to be removed from the inlet line, I'm assuming, because there's no much pressure coming.
discuss with you about what we should say to the customer as well, because
Okay.
that's quite a good find.
It's really good, fine.
Yeah, they would have been troubleshooting that.
It would have been very hard.
Yeah, to
It's
find.
only because we were able to isolate it here. Them troubleshooting on the machine is very difficult.
And with our test report, they were correct.